name is Eleni. Now you have been warned that this session will be recorded. My name is Eleni Stroulia, and I'm a professor in computing science and the director of AI for Society at the University of Alberta. And it is my great pleasure to introduce our keynote speaker, Dr. Julia Stoyanovitz. Julia is an Institute Associate Professor of Computer Science and Engineering at the Tandon School of Engineering, Associate Professor of Data Science at the Center for Data Science, and Director of the Center of Responsible AI at NYU. Her research focuses on responsible data management and analysis, operationalizing fairness, diversity, transparency, and data protection during all stages of the data science lifecycle. She established the Data Responsibly consortium and served on the New York City Automated Decision Systems Task Force by appointment from Mayor de Blasio. Julie has developed and has taught courses on responsible data science at NYU and is a co-creator of an award-winning comic book series on this topic. So Julia, please share your comics link here because it's one of my favorite readings on responsible AI. She holds MSc and Ph.D. degrees in computer science from Columbia and a BS in computer science and math and statistics from the University of Mass at Amherst. She's a recipient of an NSF CAREER award and a senior member of the ACM. So Julia, we're looking forward to listening from you on building data equity systems.
Thank you so much, Eleni, for the kind introduction and for inviting me to speak to this wonderful audience. If any of you get bored during my talk, there is a link that I shared in chat upon Eleni's suggestion, where you can just kind of half listen and half browse the comics. So, and another thing is that when I start presenting, I won't see you, but I do see chat, and you can also speak up. If there's a burning question, please feel free to bring it up, but I'll do my best to also leave time at the end for questions. All right, so let me share my screen.
Julia, I will be looking at the chat and I may interrupt you.
Sounds great. That sounds great. Okay, so and please confirm that you see my slides and not the notes, right?
Perfect.
Okay, wonderful. So once again, a great pleasure to be here and to discuss with you the challenges of designing, developing, and deploying data-intensive systems responsibly. And I will treat these challenges through the powerful lens of equity. Equity as a social concept directs us to treat people differently depending on their endowments and needs to provide equality of outcome rather than equality of treatment. Equity lends a unifying vision for ongoing work to operationalize ethical considerations across technology, law, and society. I would like to present today a vision for building data equity systems. These are complex, data-intensive systems that consider equity as an essential objective. And as I present this vision, I will give some examples of my own work done in collaboration with many wonderful and talented colleagues and students. So to start, of course, we all agree in this room that we all are working on AI. And while no universally agreed upon definition of AI exists today, I will propose a definition for the purpose of today's discussion. I'd like to think of AI as a system or systems in which algorithms use data to make decisions on our behalf or help us, humans, make decisions. When discussing AI, we usually make a distinction between systems that operate according to predetermined rules, such as Roomba, the smart vacuum, and those that learn rules from data, such as a chess-playing AI, a self-driving car, or an automated hiring system. And this distinction is certainly not strict. In fact, as we all know very well, most modern AI systems combine rules that are specified at design time with some form of learning. The examples I listed, and many more, underscore that we see substantial promise in the use of AI. We look to these systems to make the lives of each and every one of us more convenient, to accelerate science and boost innovation, and even to improve the ways in which society is governed. Yet, despite this substantial promise, the reality is that machines make mistakes. A customer service AI at your favorite online shoe store may misunderstand your order, and the wrong pair of shoes will be shipped to you. Annoying as this may be, consequences of such a mistake are not severe and they are reversible. However, there are cases where mistakes can lead to catastrophic, irreversible harms, even to the loss of human life. Consider an obvious example here, an autonomous car, an AI that is about to cross an intersection and that either does not recognize the presence of a person in a wheelchair as one of the types of objects that it would expect to see on the road, or that miscalculates the pedestrian's trajectory. For example, if the person in a wheelchair were crossing the intersection going backwards, and then the self-driving car's AI may miscalculate, and it will instruct the car to continue on its path, enter the intersection, and run the person over. To dive deeper into the conversation about the opportunities and the risks of using AI, let us consider a domain where these systems are used ever more broadly, and where the stakes of a mistake to an individual, a population group, and even to society at large cannot be overstated. This domain is automated hiring. In their 2018 report, Miranda Bogan and Aaron Rike aptly described the hiring process as a funnel, a sequence of data-driven, algorithm-assisted steps in which a series of decisions culminates in job offers to some candidates and rejections to others. The process starts when employers source candidates with the help of ads or job postings, which are often carried out on social media platforms like Facebook or LinkedIn. Next, during the screening stage, employers assess candidates by analyzing their experience, skills, and characteristics. This stage uses a variety of AI tools, including resume and social media profile screeners and games-based psychometric assessment. Through interviewing applicants, employers continue their assessment. This too is often done with the help of AI, for example, using video and speech analysis tools. During the selection step, employers may run background checks and make final hiring and compensation determinations. Why are algorithmic hiring tools so attractive? Well, first, they promise to help employers, large and small, hire more efficiently, source and screen candidates faster and with less paperwork, and select candidates who are likely to do well on the job. These tools are also meant to improve efficiency for the job seeker, allowing them to apply with a click of a button, matching them with relevant positions, and facilitating the interview process. And we also often hear the argument that the use of these tools can help us improve workforce diversity. And I personally am very skeptical of that argument. And yet this argument being made very frequently is that because humans are biased, we have no choice but to use machines to step in and hire on our behalf. I'm showing you here an excerpt from a famous study by Bertrand and Mulainathan, who back in the analog days of 2004 manipulated perceived gender and race on resumes and observed that applicants who were perceived as male and white received substantially more callbacks from potential employers on the very same resumes. So are algorithmic hiring tools living up to their promise? One of the earliest indications that there's cause for concern came in 2015 with the results of the Ad Fisher study out of Carnegie Mellon University. The authors ran an experiment and found that ads for high-paying jobs were shown far more frequently to men than to women. This brings back memories of the time when it was legal to advertise jobs by gender in newspapers. Other examples of gender, racial, and disability discrimination abound. And there's strong evidence of disability discrimination in these tools. To summarize, we are concerned about the use of AI in hiring. The effects of these systems are often discriminatory, reinforcing results of historical disadvantage. Discrimination is in turn often linked to the term bias, a term that is used by the technical community ever more frequently, but that is still poorly understood. We will discuss bias momentarily. So before diving in, where do we go from here? As a technologist and an engineer, I'd like to understand the following. Technology created or exacerbated the kinds of bias and discrimination that I mentioned? Can we use technology to fix these mistakes? To frame this conversation, I will return to the main thread of my talk, the task of building data-intensive, socio-legal technical systems, such as those used in hiring, that treat equity as a central requirement. My goal in this talk is to help us find a productive and pragmatic middle ground between two harmful extremes. One of these, depicted on the left of this slide, is techno-optimism or techno-solutionism, a belief that technology can single-handedly fix deep-seated societal problems like structural discrimination in hiring. The other extreme and harmful belief, depicted on the right, is techno-bashing, an extreme form of techno-criticism that boils down to a belief that any attempt to incorporate ethics and legal compliance into technology is bound to misfire, and consequently, that technology should be dismissed outright. To start developing a technical narrative, let me now turn to a discussion on bias that I promised. And for this, I'd like to recall a classic. In their seminal 1996 paper, Batya Friedman and Helen Nissenbaum identified 3 types of bias, excuse me, that can arise in computer systems, represented here jointly as a 3-headed dragon. And these types are pre-existing, technical, and emergent bias. Pre-existing bias is independent of an algorithm and has its origins in society. Technical bias is introduced by the operation of the technical system, and it may and often does exacerbate pre-existing bias. Finally, emergent bias arises in the context of use, and it may be present if a system was designed with different users in mind, or when societal concepts shift over time. We will fight the bias dragon with the help of data equity. My colleagues Bill Howe, H.V. Jagadish, and I coined this term. We see data equity as having 3 major facets. The first is representation equity. It refers to deviations between the data record and the world the data is meant to represent, often with respect to historically disadvantaged groups. The second facet is access equity. It's concerned with having access to information, features, data, and models needed to evaluate and mitigate inequity. Finally, outcome equity refers to downstream unanticipated consequences outside the system's direct control. I will use this classification, this trichotomy, in the remainder of my talk. So to start, let's discuss representation equity. To think about this equity facet, I like to use the following metaphor. Data is an image of the world, it's mirror reflection. When we think about societal bias in the data, we interrogate this reflection. One interpretation of bias in the data is that the reflection is distorted. We may systematically oversample or undersample particular parts of the world, or otherwise distort the readings. Another interpretation of bias in the data is that even if we were able to reflect the world perfectly in this mirror that the data presents, it would still be a reflection of the world such as it is today, and not necessarily of how it could or should be. I'd like to make a couple of points based on this metaphor. First, it's important to keep in mind that a reflection cannot know whether it's distorted. That is, data alone cannot tell us whether it is a distorted reflection of a perfect world, a perfect reflection of a distorted world, or if these distortions compound. The assumed or externally verified nature of distortions has to be explicitly stated and used as input to technical interventions. The second point is that it's not up to data or algorithms, but rather up to people, individuals, groups, and society at large to come to consensus about whether the world is how it should be, or if it needs to be improved, and if so, how we should go about improving it. This is the difficult work of democracy, and once again, it demonstrates that there are limits to what we can expect of purely technical solutions. My third and final point is that changing the reflection does not necessarily change the world. If the reflection itself is used to make important decisions, for example, whom to hire or what salary to offer to an individual being hired, then compensating for these distortions at that decision point is certainly worthwhile. But the mirror metaphor only takes us so far. We have to work much harder, usually going far beyond technical solutions, to propagate the changes back into the world, not merely brush up the reflection. Let me now give an example of a concrete technical approach that focuses on representation equity in set selection and ranking. Consider the task of selecting 4 candidates among 16 job applicants. Our goals here are twofold. The first is a particular kind of diversity. We wish to include 2 candidates of each gender and at least 1 of each race. The second is a particular kind of utility, maximizing the sum of scores of the selected candidates subject to these diversity constraints. You can see a list of candidates in the table here along with their scores. For example, candidate A has score 99 and L has score 83, and the higher score is better. Observe that male candidates have higher scores than do female candidates of the same race, and that whites have higher scores than blacks and than Asians. The highest scoring set of 4 candidates who satisfy the diversity constraints is highlighted in pink. Their combined score happens to be 373. But if we consider this selection more closely, we observe a problem. So what is the problem? It's that we picked the best, according to score, white and male candidates A and B, but did not pick the best Black, Asian, or female candidates. And note that this example was deliberately constructed to highlight the following. If some population groups have systematically lower scores, then it costs less to skip their best scoring members in the name of diversity. This runs contrary to the nature of the diversity objective that I stated, which is to equalize access to opportunity. This also represents unfairness under a particular belief system that I'm summarizing here. Suppose that scores represent effort. For example, how hard someone had to study to do well on a test. We may take a relative view of effort and assert that scores are more informative within a group than across groups. And further, we may assert that it's important to reward effort. Taken together, these beliefs correspond to Romer's Luck egalitarian conception of equality of opportunity. And I'm depicting here Romer and Dworkin. They are 2 philosophers who have popularized Luck egalitarian conception of equality of opportunity. Next, let's consider the set of 4 candidates highlighted in blue. This set still meets the diversity constraints, and its score is lower by 1 than the score of the pink set. This utility loss is inevitable, but it's very small. The blue set contains the top scoring candidates of both genders and the top white and black candidates. And so it's much better in terms of rewarding effort across groups. Having stated our beliefs and observed a trade-off between a particular kind of diversity, a particular kind of utility, and also a particular kind of fairness, we are now ready to design an intervention. For example, we may compute unfairness for a given group, like the female candidates I'm showing here, as the ratio of the score of the lowest scoring selected candidate, here that's K with score 83, and the score of the highest scoring skipped candidate, here that's D with score 95. We can then reformulate the selection process to balance this regret, this unfairness across groups. We did this and quite a bit more in the paper that I'm citing at the bottom of the slide. Designing several fairness metrics of this sort for both set selection that I just described and for ranking. We devised an integer linear program to encode various constraints that arise and ran experiments showing that the utility cost of balancing fairness is low in most cases. Let's now look at another example from the same domain, hiring, but where we will explore a different set of goals and assumptions. Consider a data set of candidates with specified gender and race. This data set is used by a moving company to hire K equals 4 best qualified candidates. Note that the score attribute X represents a candidate's weightlifting ability, which is essential for the job that they need to perform, with higher values being better. The outcome Y represents the candidate's final qualification score. Candidates are ranked in decreasing order of Y. The process by which Y is derived is hidden from us, but we do observe each applicant's attributes, including their score. We may have reason to believe, based on our knowledge of discriminatory practices in hiring, that gender, and possibly also race, impact the qualification score Y. And this is a problem that we will now set out to mitigate. We state our beliefs in the form of a structural causal model, or SCM, depicted on the right. An SCM is a directed acyclic graph where vertices represent observed or latent variables and edges indicate causal relationships from source to target vertices. The arrows pointing from gender, G, and race, R, directly to Y, encode the effect of direct discrimination. We want to check whether such links exist in our data, and if so, we want to break them. And these links are shown in pink. Additionally, the SCM can encode indirect discrimination. G and R both impact Y through weightlifting ability X, called the mediator variable. Now, the question is, should we or should we not allow gender and race to impact X? We have the flexibility to state that if impact of race on X is determined to be in effect in our data set, then we want to disallow it. On the other hand, the impact of gender on weightlifting ability can be considered legitimate. The SCM on the right encodes these beliefs. In it, X is treated as a so-called resolving mediator with respect to gender, but not with respect to race, as denoted by the color of the corresponding arrows. So how do we use our beliefs, stated as a structural causal model, to inform an intervention? The idea is to compute scores, treating each individual in the sample as though they had belonged to one specific intersectional group, for example, Black women, and then rank on those scores. In a nutshell, the counterfactual score Y is computed by replacing the observed value of a sensitive attribute with the counterfactual, and then propagating this change through the structural causal model. Any directed descendant of sex or race, gender or race, has its value changed by computing the expectation of the new value of the sensitive attribute. And this operation is iterated until it reaches all the terminal nodes that are descendants of any of the sensitive attributes. If a mediator variable is non-resolving, then its value will be set to its counterfactual value in the process. If, however, it is designated as resolving, then we keep its observed value. The resulting ranking will be counterfactually fair, and we will use it to assign outcomes. For intuition, you can imagine all individuals in the data who have sufficient weightlifting ability, whether they are men or women, white, Asian, or Black, to look like Brienne of Tarth from the Game of Thrones, only darker, like the image on the top right of the slide. And additional details, including experimental results that showcase the flexibility of our proposed method, can be found in the paper that's cited here. I discussed two of many possible technical operationalizations of substantive equality of opportunity in set selection and ranking. I'm showing here a recent two-part survey on fairness in ranking that I co-authored with Mike Zelike and Kay Yang, and that appeared in ACM Computing Surveys just a few days ago. The first part of the survey looks at fairness in score-based ranking, and the second part looks at fairness in learning to rank and in recommender systems. This survey is motivated by there being a lot of work on incorporating fairness requirements into rankers with contributions from a wide range of communities: data management, algorithms, information retrieval, and recommender systems. We observed that many fair ranking methods establish their own understanding of fairness, but they stop short of categorizing themselves with respect to the normative frameworks that they embed. And this makes it difficult to understand what values these methods encode, in what specific scenarios they are applicable, and how they relate to one another. And further, methods differ on the technical choices they make, including, for example, their data representation choices. These technical differences are not value neutral and have profound implications on the applicability of the methods. In our survey, we develop a common narrative around the value frameworks that motivate specific fairness-enhancing interventions in ranking. We offer a broad perspective that connects formalizations and algorithmic approaches across subfields, which in turn allows us to see the methods through a common lens and identify trade-offs. I'm showing the classification framework we proposed on this slide, visualized as a mind map. You can see several normative dimensions here, including the equality of opportunity doctrine and the worldview, the type of bias that the method aims to address, whether it responds to concerns about intersectional discrimination, and what type of group structure it supports. At this point, I'd like to switch gears and discuss access equity. Access equity is concerned with having access to information, features, data, and models that are needed to evaluate and mitigate inequity. The point of view I will take here is primarily of mitigating technical bias, making sure that we're able to catch and correct for the imperfections and distortions in the data as it travels through complex data science pipelines. Why am I taking this point of view? Well, much exciting work is done by the fair machine learning research community, but it considers this work out of scope. Their focus is on predictive analytics that take as input a nice, clean, rectangular data set, crunch it, and produce a result. If we then notice that the result is such that no women are shown ads for high-paying jobs, and no Black candidates are invited for job interviews, then we have three choices. We can tweak the input data, for example, upsample or downsample some groups. We can tweak the algorithmic box, for example, add a regularization term, or we can tweak the result, for example, reassign outcomes. This is a useful exercise, but it's a limited view. I'm showing it here as fighting a paper dragon in practice. To be able to understand and address these issues in the real world, in production, we need to expand our scope and start asking what specifically happens inside the box, how the results are used, and notably where the data came from. And this last point, where the data came from, is something that I will dwell on for the next few minutes. And this essentially amounts to taking a lifecycle view of equity, which I think is required. I will explore this view by discussing the impact of different steps in the data lifecycle, including cleaning and integration, on the properties of the result. And here, let me give another concrete example. Consider Anne, a data scientist in a human resources department at a large retailer. Anne was asked to develop a model that predicts the level of compensation to offer to promising job applicants, to make sure that they are, in fact, successfully hired. Anne includes candidates' self-reported demographic data together with their employment histories as input. Following her company's best practices, Anne starts by splitting her data into training, validation, and test. She then implements data pre-processing, such as combining, joining data from the two input tables, interpolating missing values. And then she performs model selection and finally tuning and validation. Next, Anne considers the accuracy of the trained model and observes a disparity. Model accuracy is lower for women than for men, and most mistakes for women are such that the model would predict a lower salary for them than they would expect. That is a technical deficiency in our system, a particular kind of disparity in accuracy, leads to potentially lower salaries for women, reinforcing the gender wage gap. How would Anne go about understanding the cause of this issue and mitigating it? Thankfully, in part based on her own lived experience, Anne has a hunch. She goes back to data preprocessing and observes that the value of the feature that encodes the number of years of experience is missing far more frequently for women than for men. And the key observation that we will now explore is that years of experience is a strong proxy for age. Anne's classifier uses years of experience as one of the features, and so it means that the value of this feature had to have been interpolated, filled in, guessed, in Anne's pipeline. Anne takes a look at data imputation and notices that she took the default that was offered in scikit-learn, replacing a missing value with the mean for the population. Now, why is this problematic? Well, it's because it will skew these missing values lower, effectively skewing the older applicants younger, and it will in turn result in a lower salary being predicted. I'm depicting this here. So this is what the true distribution of years of experience looks like. Values of this feature are missing, once again, more frequently for women, and specifically those who have a longer employment history, and thus those with higher salary requirements. When Anne understands this, then she replaces mean imputation with a state-of-the-art data imputation method that fills in years of experience in applicant data and successfully mitigates the shift in the data distribution and the disparity in errors that she observed earlier. To summarize this example, the problem was due to an erroneous assumption that was embedded into the missing value imputation method of Anne's pipeline, that values of years of experience were missing at random. That is, whether a value is missing doesn't depend on what the value itself is. But this assumption often does not hold in practice. The example I just gave illustrates this. Experience is a proxy for age. Higher values of experience are omitted more frequently. Why might that be the case? Well, it's because applicants may be worried, and rightfully so, about age-based discrimination in hiring. Let's extrapolate on the age example. Consider a form that gives job applicants a binary choice of gender and also allows them to leave gender unspecified. Suppose that about half of the applicants identify as men and half as women, but that women are more likely to omit gender. Then if mode imputation, that is replacing a missing value with the most frequent value for the feature, which is again the default in scikit-learn, is used, then all predominantly female unspecified gender values will be set to male. More generally, multi-class classification for the imputation of categorical features typically uses the most frequent classes as target variables, leading to a distortion for small population groups because membership in these groups will never be imputed. Next, suppose that some individuals identify as non-binary. Because the system only supports male, female, and unspecified as options at input, these individuals may leave gender unspecified. If mode imputation is used, then their gender will be set to either male or female. This example illustrates that technical bias can arise from an incomplete or incorrect choice of data representation. And importantly, it has been documented that data quality issues often disproportionately affect members of historically disadvantaged groups, and we risk compounding technical bias due to data representation or other technical choices with pre-existing bias for such groups. As another simple but often overlooked example of technical bias, consider filtering operations like selection and join. Filtering can arbitrarily change the proportion of some demographic groups in the data, even if they do not directly use the sensitive attributes such as age as part of the predicate or of the join key. This change in proportion may be unintended and is important to detect, particularly when this happens during one of the many pre-processing steps in a data-intensive pipeline. During model development, Anne may have filtered the data by zip code or county to get a sample that is easier to work with. Demographic attributes such as age and income are highly correlated with places of residency, and so such a seemingly innocent filtering operation might have heavily biased the data. Another potential source of technical bias is the increasingly common usage of pre-trained word embeddings. For example, Anne's code might replace a textual name feature with the corresponding vector for a word embedding that is missing for rare non-Western names. And this would be due to lack of data representation in the training corpus. If we then filter our records and filter out those for which no embedding was found, we may disproportionately remove individuals from specific ethnic groups. As my final example in this segment, consider the impact of the join operation, where data from two tables, in this example, patients and healthcare spending, is combined. The data is also implicitly filtered. A combined record is only generated for individuals for whom both a patient record and a healthcare spending record was present. In my example, if fewer healthcare spending records exist for patients of particular demographic groups, then they will be missing from the join result. In a recent line of work done with the talented Stefan Grafberger and Sebastian Schelte, we developed ML Inspect, a lightweight data distribution debugger for data pre-processing pipelines. The ML Inspect library extracts logical query execution plans modeled as directed acyclic graphs of pre-processing operators from machine learning pipelines that use popular libraries like Pandas and scikit-learn. And we combine relational operations and estimator transformer pipelines. These plans are then used to automatically instrument the code and trace the impact of operators on properties like the distribution of sensitive groups in the data. In the remaining time, I would like to address the final and perhaps the most difficult dimension, and that is outcome equity. It is concerned with whether and how we can assess and mitigate inequities that are outside the system's direct control. My thinking about outcome equity centers around interpretability and public disclosure. I like to think about interpretability using the nutritional label metaphor. I'm depicting a nutritional label on the left of this slide. The data management and knowledge management communities have been studying systems and standards for metadata provenance and transparency for decades. The needs of data equity systems are once again bringing these favorite topics into the spotlight, but with a twist. To differentiate nutritional labels from more general forms of metadata, my colleagues and I articulate several properties. We think that labels should be comprehensible. They are not a complete and therefore overwhelming history of every processing step applied to produce a result. The information on a nutritional label must be short, simple, and clear. Labels should be consultative, providing actionable information, not just descriptive metadata. Based on this information, consumers may cancel unused credit cards to improve their credit score, and job applicants may take a certification exam to improve their chances of being hired. Further, labels should be comparable, enabling comparisons between related products and thus implying a standard. And finally, they should be composable and computable, derived automatically or semi-automatically as data and decisions are produced by complex multi-step systems. In a recent article in the Wall Street Journal, I wrote about how this metaphor can be used to provide the necessary insight into the hiring process to job seekers. Here's what such a label may look like for the application part of the process. I call this a posting label. A similar label called the decision label would be generated to explain the hiring outcome to an individual. I wrote this article in response to a proposal for a law that has since been passed and is set to regulate the use of automated employment decision tools in New York City, where I live. The bill was passed in December of last year, and this law prohibits the sale of such tools if they were not the subject of an audit for bias. It also requires to disclose to candidates when such tools are about to be used to assess their candidacy for employment, and also to disclose what job qualifications or characteristics would be used in the screening. We need to work together to understand what a bias audit should look like, and also how we would go about public disclosure, about explaining to job seekers which qualifications and characteristics are about to be used and why these are relevant. As part of this work on outcome equity, I'm engaging with colleagues in social psychology at NYU on a framework that forms connections between interpretability and trust, and develops actionable explanations for a diversity of stakeholders, recognizing their unique perspectives and needs. We propose to think about interpretability and explainability by asking and seeking answers to three simple questions. What are we explaining, to whom, and for what purpose? What do we expect these individuals to do with this information? An important point is that individuals and groups who distrust algorithms may be less likely to harness the potential benefits of new technology. And in this sense, interpretability once again intimately relates to equity. Recent studies found that individuals who are more familiar with AI fear it less and are more optimistic about its potential social impacts. I'd like to share my ideas about transparency and public disclosure with you by stepping through a job posting nutritional label. This label should accompany a job ad and be available to a potential applicant before they apply. The primary purpose of a posting label is to support informed consent. On the left, we see required qualifications. And this particular posting is for an accountant's position. So one of the qualifications is knowledge of the financial system. Another is a bachelor's degree in accounting with a high grade point average, and also demonstrated success in team projects. Based on this information, a job seeker can decide whether they meet the qualifications for the position. Next, the job seeker sees what data will be used to screen them. This includes their resume, their LinkedIn profile, and the credit score. And all these data sources are required. And finally, the potential employer may use other social media, but they give the job seeker an opportunity to opt out. For example, Facebook, Instagram, and Twitter here are marked as optional data sources. Finally, the job seeker can see what type of assessment they will undergo. There is AI-assisted personality screening, which is required, and a personal interview where the applicant can request disability accommodations. I'd like to dwell for a moment on the AI-assisted personality prediction component of the hiring process. What is that all about? Since the early 1900s, personnel selection practices have relied on the use of psychometric instruments, such as personality tests, to identify promising candidates. Two models of personality are in widespread use. They're called DISC and the Big Five. DISC is a behavioral psychology test that assesses the extent to which a person exhibits 4 personality traits called dominance, D, influence, I, steadiness, S, and conscientiousness, C. The Big Five model contains 5 traits, and these are openness, conscientiousness, extraversion, agreeableness, and neuroticism. And these are traits that human resources specialists are often instructed to assess during in-person job interviews. And although the practice of personality prediction is hiring is both long-standing and widespread, it has been met with skepticism from industrial organizational psychologists, or IO psychologists, due to validity and reliability concerns. And it even led to disagreements about whether personality itself is a meaningful and measurable construct. Specifically regarding DISC scores, scholarly work in IO psychology has been limited, especially with regard to its validity and reliability for hiring. And the DISC website explicitly states that these scores are, I quote, not recommended for pre-employment screening, end quote. As of late, we have been seeing numerous commercial systems that claim to extract DISC, the Big Five, and other traits from applicants' resumes and social media profiles. This process is depicted on this slide. Resumes, LinkedIn profiles, and social media feeds are used as inputs to these systems. These inputs are processed to automatically construct personality profiles. And these personality profiles are then offered to hiring managers to inform the hiring process. In summary, algorithmic personality tests use insights from psychometric testing and promise to surface personality traits that are indicative of future success based on job seekers' resumes or social media profiles. In a recent paper that I co-authored with a large interdisciplinary team that includes data scientists, a psychologist, an investigative journalist, and an IO psychologist, a sociologist, sorry, I should have said, we interrogated the reliability of such systems using stability of the outputs they produce, noting that reliability is a necessary but not a sufficient condition for validity. We developed a methodology for an external audit of stability of such tests and used it to audit two systems called Humantic AI and Crystal. And importantly, rather than challenging or affirming the assumptions made in psychometric testing that personality traits are meaningful and measurable constructs and that they are indicative of future success on the job, we instead framed our methodology around the assumptions that are made by the vendors of these tests themselves. In our audits of Humantic AI and Crystal, we found that both systems show substantial instability on key facets of measurement, and so cannot be considered valid testing instruments. For example, Crystal frequently computes different personality scores if the same resume is given in PDF versus in raw text, and these are both formats that they accept. While Humantic AI gives different personality scores on a LinkedIn profile as compared to a resume of the same job seeker. This violates the assumption that the output of a personality test should be stable across job-irrelevant input variations. We also found notably evidence of persistent and often incorrect data linkage by Humantic AI. Additional details can be found in the paper that's cited here. So finally, and I know that I should be wrapping up, I'd like to share that I'm also passionate about educating technical students about responsible data science. I developed and have been teaching courses on this topic at NYU. The course I'm showcasing here has already been taught for 4 years, and it has been able to attract a demographically diverse and engaged group of students. All course materials are publicly available online at the link on this slide. And I will also note, as I did already, that I have been developing comics. So one of these is the Data Responsibly comic book series. Its first volume has been translated into Spanish and French. Please take a look and share broadly. I use these comics as supplementary reading in the course that I described. Another set of activities that falls under the outcome equity umbrella is on developing public education materials and methodologies on AI and ethics. I'm showing here a course that I've developed together with colleagues and that is being offered and has just been offered for the first time in person at the Queens Public Library in New York City. The course is called We Are AI. We Are AI is a collaboration between the Center for Responsible AI at NYU that I direct, Peer-to-Peer University, a public education nonprofit, and the Queens Public Library. Materials for the course include a series of videos and a comic book series. Both can be used independently of the course. Everything is in the open source on GitHub and on YouTube. I'm showcasing the comics here. Please take a look and share. We recently also ran a series of workshops aimed at improving the accessibility of We Are AI, both the comics and the course, across a range of abilities and levels of technical expertise. Stay tuned for an improved version of the comic with better accessibility and 4 guidelines for creating accessible educational materials. And we just released a Spanish language edition of the comic series yesterday, in fact. So it's now time to wrap up, and I'd like to leave you with a few parting thoughts. In my talk, I gave a perspective on data equity systems. I grounded this discussion in automated hiring tools, a specific use case that gives us ample opportunity to appreciate potential benefits of data science and AI, but also to get a sense of the ethical and legal risks. It's clear to me that we, technologists, have an important role to play. But to make progress, we need to carefully negotiate between the 2 harmful extremes of techno-optimism and techno-criticism depicted here. Additionally, we must step outside our engineering comfort zone and start reasoning in terms of values and beliefs, in addition to checking results against known ground truths and optimizing for efficiency objectives. This seems high risk, but one of the upsides is being able to explain to our children what we do and why it matters. Another point I'd like to make is that we cannot fully automate responsibility. While some of the duties of carrying out the task of, say, legal compliance can in principle be assigned to an algorithm, the accountability for the decisions being made by a data-intensive system always rests with the person. This person may be a decision maker or a regulator, a business leader or a software developer, or most importantly, a member of the public. And for this reason, I see the role of us technologists in helping build systems that expose the knobs of responsibility to people. Of course, these systems that we're helping build are not simply technical, they are socio-legal technical, and technology is in some sense the easy part. This means that to expose the knobs of responsibility to people, we must work together to create meaningful regulatory mechanisms, a topic that I'm very interested in and on which I was only able to mention in passing today. I also see as part of our responsibility as technologists and educators to help create a new generation of AI practitioners and an informed public. For a very engaging look at algorithms, computation, data, and their impacts on society, I highly recommend the recent book called The Age of Algorithms by Serge Abidbul and Gilles Dovec. I'd like to end my talk on a quote from this book. Algorithms are probably the most sophisticated tools that people have had at their disposal since the beginnings of human history. They have transformed science, industry, and society. They upset the concepts of work, property, government, private life, even humanity. Going easily from one extreme to the other, we rejoice that they make life easier for us, but fear that they will enslave us. Slightly paraphrasing from the book, creations of the human spirit, algorithms, and AI are what we make them, and they will be what we want them to be. It's up to us to choose the world we want to live in. Thank you very much for your attention. The graphics you saw in my talk today are due to the very talented Fala Arif Khan, who is a data science researcher and an artist. Thank you.
Wow. Thank you so much, Julia. We have not much time, but we have a break between now and the next event. So I want to open the floor for 1 or 2 questions. I know I have tons, but I will not get started.
I'm very sorry to have almost run over time.
Well, you have a lot to talk about, so I think I can forgive you. Okay, so people are thinking, let me ask you something that you cannot answer quickly. Hiring faculty members. It's not about who you are, it's not only about who you are, it's also about how you change the place where you're going to be hired to. How can we be fair in that context?
Yeah, this is an excellent question. And in fact, I think that this is also applicable to other types of hiring, right? And faculty hiring is maybe an extreme example of this, but one of the fallacies, I think, that exists in this space of kind of bulk hiring with the help of algorithms is that companies expect to find a fully formed person, like a unicorn, right, who's going to be perfectly formed and have all the right qualifications, and that's going to be both necessary and sufficient to do the work that they're being hired for. But in fact, as we know, the culture of a company has a huge role to play, and companies have a responsibility to make sure that the talent they hire gets opportunities for development, right? So it's, frankly, I think it's to a lesser extent on the job seeker to prove that they are going to be a positive force at the company. And it's more on the company or a university in this case to, in fact, be able to attract and build and develop diverse and creative talent.
Absolutely. One last offer to the floor. Well, you gave us a lot to read and a lot to think about. Thank you so much. And I'll do it on audio too.
Thank you very much. A pleasure.
So Ibrahim, can you give us instructions of what we're doing next?
I think we are going offline for about 30 minutes, coming back.
Yes, for the panel.
For the panel at
what are we coming back?
We are coming back at 2 p.m., which would be what, 12 noon your time? Is it?
And
in half an hour.
And what link are we using?
Same link as the one
okay.
we're on.
So
yeah.
See you all in about half an hour.
Yes.
Thanks again, Julia.
Thank you, Julia. Excellent.
Oh, Richard.
Yeah, actually, well, since it's ending anyway, I thought I might slip in a quick question.
Sure.
Please.
Yeah, it could count as discussion as after the meeting. I'm just wondering, wanted to have your opinion on this, Julia. Data collection in the past and up to right now, we are very adverse to collecting information that could lead to bias. So race, gender, those are almost never collected in our data sets.
Right.
But they are vital to detecting biases and discrimination in our algorithms and our results. All your examples needed that information.
Right.
Of course, we could infer it from proxies, but then it becomes a probability, an imperfect probability of discrimination. So do you feel that we should reverse this practice, that we should instead start documenting all these personal characteristics of the people represented in our data sets?
This is an excellent question, right? And it's one of the elephants in the room here. So fairness through blindness is a blunt instrument that is more harmful than it is helpful, right? And this is, I think, what you're pointing out. So in the US, we have this doctrine of disparate treatment that says that you cannot use membership in various protected groups. For example, you cannot use anyone's gender, whether it's majority or minority, right? To make individual level decisions about them. And yet the doctrine of disparate impact tells us that decision makers are in fact responsible in a number of domains to show that they don't discriminate at the group level against people who belong to historically disadvantaged groups, right? So these doctrines, they contradict each other, as do many fairness approaches. But what I think we need to do here, and there's no quick and easy answer, is that yes, in fact, it would be very helpful to have access to information about people's socioeconomic status and ethnicity and disability status to be able to make better, fairer, more robust decisions about them. But this has to come with a solid data governance mechanism and data protection and data literacy really being embedded throughout our systems so that people understand that when they submit this data, it's only going to be used to their benefit, so to say, right, rather than to disadvantage them. And furthermore, to give people control, right, over how this data is collected, how it's used, and when it's discarded. And this is not just about trust. It's not just about people, in fact, trusting the system with such sensitive data about them. It's actually about rebuilding the systems to build advanced, sophisticated data governance mechanisms into them. And we're very far from that, right? So I think that this is our task for the next few decades, frankly.
Thank you. And yeah, I think you're absolutely right, because if we start collecting ethnicity, for example, about our data, it would be better for data sets for algorithms, but people from ethnicities or races that have been historically discriminated against will be hesitant to provide information, and in turn will be even less represented than they already are in our data sets.
Right. But we should not disregard that in the processing, right? So that was my point in the technical bias conversation, is that it's exactly the people who are disadvantaged who won't tell you how old they are or whether they are disabled.
So data governance is going to be vitally important in that, robust data governance.
Data governance, and also an understanding that that there's a distributed responsibility and accountability, right? So that people have all need to learn about these things and care about them.
Absolutely. Thank you very much.
Thank you for the question.
So Julia, if you are available, people have asked that we keep this channel open until the next event.
Yeah,
so
I'm around.
There are many burning questions.
Of course.
Next one is Yuta, and I see you, Kira, also.
Yeah, and thank you, Julia. That was wonderful. I just to continue the conversation that just started, and look at disability. Disability mode. I mean, there is not only a reluctance to self-identify, which is greater in certain cultures and at certain ages, but there's also many people don't actually identify, despite the fact that they have a disability. And the identification there, or the data clusters of any proxies that you would use to determine whether someone has is just so diffuse and different, unlike language or gender or any of the others. So the bias is actually against human difference. And how do we address that within employment? Is I mean, there are systems like what Daniel Lee and company have explored, where we're moving from a data exploitation to data exploration algorithm to increase the diversity. But those types of strategies, how do you apply those when the bias is against just human diversity, human difference from the norm, from the target success criteria or the persona from the past? And of course, these hiring systems, the filtering systems, they are using things like persona matching, culture fit, etc., which it might be easy to determine whether there is differential treatment with respect to very well-defined bounded groups. But when you have such a diffuse, diverse group, how do we tackle that?
Great question. I absolutely don't have an answer. And in fact, I don't know whether my skepticism about algorithmic hiring really came through in this talk, but I'm extremely skeptical. And
of course, the personality.
That's just
the personality science is such snake oil. It always
exactly. I mean,
now that we're moving it into that we're actually automating it and mechanizing, it's so scary.
And it's complete nonsense, right? I mean, this is why I actually inserted that bit about this paper that's going to come out at AS this year in August about personality testing, where, you know, my colleagues and I, including of course, the sociologist, but also the industrial psychologist on the team, none of us believe that any of these constructs are valid, but it's our word against theirs, right? So how do you actually show that the thing is nonsense? Is you have to use their own assumptions. And I think that it's going to be a very long battle that we all collectively fight here to call them on their bullshit. I have to use the word because that's the appropriate scientific term here.
I'm so glad you're doing that.
Yeah. So yeah, the disability, I absolutely agree with you, as you know, Yuta, right? That thinking about how individuals with different abilities, not even disabilities, right, but just different people, how different people are treated by various systems, if we cannot convince ourselves that we can treat people with respect and inclusively with the process that we have set up, whether or not it includes algorithms, we should not use that process. We should rethink that process.
Yeah, we should think HR in general. But
in general, right? But so maybe an opportunity now that we have is that some of these decisions are somehow getting out of people's heads and into these algorithmic systems where perhaps we have a better chance of figuring out what's going on, right? I mean, this might be one promising argument here, is that maybe we can use AI to externalize some of these biases and some of these bad practices, and to measure and to then reflect these practices back, right, into the practice. And this is something that I'm very interested in. We're actually now working on a large-scale study to understand, with the help of qualitative methods, how HR specialists even use these tools. This is not documented. We don't know which tools are used, how, to what extent they're prevalent, and where they fit into the decision pipeline.
Yeah, we're doing a
question
survey.
So
we should share that. Yeah.
Yeah, we should talk. Certainly, we should talk about this. Yeah, but I think this is very badly needed. And again, I agree with you, Yuta, that if we don't know how to deal with the question of treating individuals with disabilities to our satisfaction, something is wrong, and we should always be asking this question.
Thanks.
Kira?
My comment flows extremely organically from this. So I'm actually a historian and I've worked on the history of personality testing.
Great.
So yeah, and so one of the things that struck me, in your talk and in, my broader kind of understanding is both that, the same concerns about these have been echoed throughout their history, right? So they've been used in the 30s. And so on the one hand, I think the AI and the current uses are something different, right? We have this kind of new set of technology. We have a broader data set to draw on. There's more, but on the other hand, the concern specifically about the opacity of like how they actually are using to come at decisions in these high stakes situations. Like you can find very similar concerns, kind of the length of their history, which I think points to like, both a need to like look at this longer history, but then also need to think about the way that these technologies get used in these kinds of high stakes situations, such as hiring. So I was really interested in that, and also really appreciate your approach, because I've seen other, audit approaches that kind of, as you were saying, like they take the claims almost at face value and say, okay, how can we make it more fair? How can we make sure that like protected attributes like, gender aren't distorting the system, but that they're already built, the idea that you can have like a contract of social conscientiousness that you can determine from someone's LinkedIn profile and then use it to hire them is multiple steps, right? And so I'm not someone who doesn't think that any personality psychology has its own, but the way it kind of gets applied specifically in these kind of systems is has a lot of problems. I think is a really good case study of some of the really problematic claims around these technologies that get implemented. And I am interested in, I think your point too about the way that HR, we actually don't have a great understanding. And I always got asked that when I talk about it, like, but how do they actually use the personality test in the hiring process? And that is, there's kind of, in a way, that itself is the black box, because none of these systems immediately like, we're going to give a personality score and that's going to be the determination. It's one part of this whole package, and that's where our hiring also gets thorny, because it also encounters the law and it encounters like these various domains where you have to make a decision. And so, yeah, it's always been a very messy issue, but thanks a lot for would love to chat further too about
me too. I'd love to chat.
Yeah,
because I don't know, whatever I know about the history of this, I know through this, it's been a 2-year project, right? I mean, this is a pretty substantial effort, but I'd love to learn more. But yeah, absolutely. So what the example that you gave, right, that says, oh, let's just make these systems more fair. This is a classic example of fair washing, right? This is like whitewashing, but fair washing. Once you engage with systems in this way, you are acknowledging that the premise is valid, right? Well, in this case, I'm not prepared to acknowledge that at all.
Right.
Yeah.
Oops. So I don't see any hands, and I want to follow up a little bit on these two systems. How prevalently are they used? I do not know about them, and I have heard about numerous use cases that use systems and drop them, but I do not know how these things are similar or different to the tools that have been used and dropped.
Yeah, so I'm just looking up in this paper to give you an actual quote about the prevalence of these systems. They are in broad use, and these two are just two examples of systems that construct personality profiles. We have information from their website, essentially saying, who their clients are. I would need to look up the exact phrase, but these are not, nonsensical sort of pilot systems. The way that we engaged with them, Crystal in particular is a well-established company, and they do various types of, employment and hiring analytics. This is not the only product that they offer. We didn't tell them that we were auditing them. We actually paid for their subscriptions. They're pretty expensive. We were only able to run this for a few months because we just didn't want to continue paying into the pot of this,
And that was one of my next questions, because basically I was guessing that they were not particularly willing to work with you guys, so they did not.
We wouldn't have worked with them. We actually didn't want to do a cooperative audit. We wanted to do an external one.
Yeah, absolutely makes sense.
Yeah, so on their website, Humantic AI reports that it's used by Apple, PayPal, and McKinsey, while Crystal claims that 90% of Fortune 500 companies use their products.
Okay.
So these are some significant players.
Reza, are you thinking about a question? You're muted.
I was trying to raise my hand. It was sometimes
I noticed you switching on your video, so please go ahead.
Yeah, so thank you so much, Julia. It was a great talk. Just based on the last point that you made, that the premise is still not very well known social sciences, which I know very little and I almost know nothing, is not as deterministic as the hard sciences. So there are lots of unknown, and there are lots of theories that will be contradicted very, very quickly. So, sorry, okay, so sorry, I don't know where there was, I thought there's another question going on. So is it fair to say that the method, specifically for the score that you were computing at some point using optimization methods, for example, to balance between fairness and the other properties of equity, is a little bit perhaps might be at some point. I'm trying to be very careful in the word.
Oh, just say it directly.
No. I mean, sometimes misleading to judge about whether the system is fair or equitable or other properties that we do care. Rather, if we use the approach for tracing back, as you made, in fact, the point in the very last part of the discussion, that the method is mostly for us to reveal what's going on in the algorithm, and without just relying on a score to decide what we should do. It's not a prescriptive; it's mostly a descriptive approach with giving us a traceable way to find out what's going on in the algorithm, and then deciding based on our moral and other, ethical framework, decide what needs to be changed. So I'd like to have your thought on.
Yeah, I understand the question. So I think that we should be using, to the extent possible, algorithmic methods, not only to reflect, but also to act. And the state right now is that these methods are being used already anyway, right? So the work that I do, it starts with stating the assumptions that you want to make. And then it is going to implement technology, right? Develop these algorithms that are consistent with those assumptions. And this is why I like in particular structural causal models, because the assumptions are very clear, right? They're given a priori. I don't mine that model from the data. What I can do is I can postulate a model, and then I can fit it over my data set and see what the parameters are. So is there or isn't there actually signal from gender to hiring, from race to hiring, right? So in that sense, the tool is, of course, introspective, right? But ultimately, I think that if we're very, very clear about what specific notions we want to pursue, and there isn't going to be a single fairness one, just like there isn't a single accuracy one, right? I mean, think false positives, false negatives, and try to reconcile those, right? So it's the same thing everywhere. As long as we're not claiming that this is, the best thing after sliced bread and is usable in every situation and is context agnostic, this is one thing that people do a lot, unfortunately, still in the technical realm, as they say, here's a general purpose fairness, box, and you just plug it in and you're good to go. And that doesn't work ever. So I don't know if that was a coherent answer, but yeah.
No, that was very good. If I can articulating that and then just explaining what's going on and how should be used. That's, I think, is very important. Thank you. I have one more technical question, but I will wait for Graham to ask his question, and then if there was time, I will ask that question.
And since there is a little bit of a break, I'll say goodbye, Julia. Thank you so much. I have to go for the next one. Bye, everyone.
Bye-bye.
Bye.
Julia, thank you for the wonderful talk. It was very inspiring, and I learned a lot.
Thank you.
I wanted to ask you about the We Are AI course that you put together for more of a public audience rather than academic audience, as I understood. And at our university, we've also received some funding recently, and we're just beginning the development of a course that would assist with building algorithmic literacy in the broader population. So I hate this idea of each university sort of building their own course, and especially like given that you have open source your materials. So do you have just some advice for other say countries or regions that want to deploy public education campaigns like this and best use of existing materials and sort of regionalization? Are there other jurisdictions using your courses and extending them?
So I'm not aware of anyone using the course as of yet. It's been several years in the making. We were hoping to pilot it last year or the year before even, but of course COVID got in the way. And the way that this course is set up, and I think this is very important, is it's a peer learning modality. It's called the learning circle, where people actually come together. These are adults. They come to the library and they discuss a topic. So it's like a generalization of a book club, essentially. You can see it in that way. And we really couldn't do this effectively during COVID and online. So unfortunately, we're a little bit behind on this, but let's definitely talk. I'd be thrilled if you wanted to build on some of the materials, to use them as they are. We are iterating on this quite intensively now. I mentioned that we did accessibility workshops, that we started some work around this to make our first target is plain language accessibility. And then we also want to make sure that the visuals are accessible to people who have different learning styles, that the text is accessible to people with different learning styles. I've gotten really good feedback anecdotally from people who live with, for example, attention deficit disorder, who said that comics are actually quite useful for them to be able to follow a storyline through, that it's easier to read this type of material than to read linearly. And then we also got some suggestions about how to group text, how to kind of remove some of the distractions to achieve some of these goals. So this is going to be an ongoing project. I'd love to partner. I think it's very important to make sure that the examples resonate with the people on the ground, right? So this is a New York City based course because we live in New York, and I don't believe that we should be trying to generalize way before we're able to figure things out locally. And so some of the examples that we use here, of course, I use hiring because I'm just such a, I'm so interested in this domain and it's so impactful. But we also use things like child protective services that people can relate to. And then we talk about autonomous cars, etc. So I'd love to sit down and see which parts kind of can be applied more globally and where there is opportunity to customize. But I think that the overall modality actually is working quite well, that it's a combination of this material that you can follow yourself with some videos that I recorded and with hands-on exercises and also these comics.
Okay, thanks a lot. I'm interested in following up. Also knowing how AI might help with some of this adaptation, right, to different learning styles. But this is sort of opening another can of worms, but maybe AI can actually be used in that adaptation process.
That would be a great use of AI, certainly, right? Yeah.
Sorry, Graham, just quickly, what did you say you were planning to build for university level AI, non-technical people? What's the goal?
Yeah, so CAREER has received funding. I can't even say publicly because it's to be announced in this month, but it's a sizable donation to develop courses for algorithmic literacy across Canada. So we'll make a public announcement, but I hate to develop something that Julia's already developed, but as she says, there's a certain amount of localization or regionalization that needs to be done. So it would be nice if each entity that's working on these sorts of initiatives can collaborate and learn from each other.
Yeah.
And then, sorry, go ahead.
No, I just want to say, if you end up developing things that we could use, we have at Ryerson, other faculties have expressed interest in understanding what AI is, and we were thinking about developing courses for them, non-AI people who are interested in knowing how they can apply AI. So if you're doing that, I don't think we should be replicating that effort. So
we should all be talking.
Yeah, let's definitely talk. And then the last thing I'll say here is that so in Europe, for example, there's a very successful effort from this company called Reactor that partnered with the University of Helsinki to produce a course called The Elements of AI. And that course is part of the high school curriculum now in various EU countries, but it's purely technical. And I think that this is a big distinction between my course and Reactor's, is that I don't believe that, a member of the general public is going to care about AI just for the technology of it. I think that there needs to be this interleaving from the get-go of what is AI, but then why do I care? And maybe why do I care first, right? And this is something that we tried really hard to embed into our We Are AI.
I'm sorry to be just jumping in. I'm sorry I missed your talk, Julie. Very sorry now that I'm jumping in and hearing this, because at CFAR, we have been working with partners to develop an introduction to AI course for the public. And we're getting ready to launch that very soon, so we should connect.
So I'm putting my email here.
Great.
Please be in touch, and then let's speak. This is one of the projects that is really the most top of mind for me at the moment.
Great. I will connect with you.
Great.
So thank you very much, Julia. I'm going to stop recording here.